Hello, my name is Sara Inani, and this is my Physics 2211 Lab 1 presentation. In this lab, we're observing a body moving with a constant velocity and basing it on Newton's second law. In simple words, Newton's second law can be written as change in velocity divided by change in time equal to F net divided by mass, where we're taking F net equal to 0. Thus, we have no change in velocity, we have a constant velocity. We connect this to Newton's first law, which states that every object persists in its state of being or moving uniformly straight ahead unless that forces to change its state of being. I am testing this using an object, a thread spool holder. I recorded its movement, edited it, and used Tracker to analyze its motions. Next, I used GlowScript to get its computational motion. Then I compared the graphs of these two. My graphs showed me the correlation between the observed and the computational motion, and to what extent we can predict an object's motion using Newton's second law. So as we can see, through Tracker, I observed an almost constant velocity. The beginning is probably due to it still being in its state of release, but then in a bit, the velocity gets constant. Through the data produced on the right, I get all the information that I need to calculate my velocity. So the mass was 0.05 kilograms. The start time and the second time I took were 0 seconds and 0.33 seconds. So using the formula to calculate the velocity, I got it as 0.13 meters per second moving in the plus x direction. Next, I used GlowScript and updated the starter script given to us using the position and the velocity, setting F net equal to 0, and I also updated the code in line 63 and 65. We run a while loop to plot the position versus time graph. As we can see on the very left, that is the plot of position versus time on Tracker, while the second image shows the computerized motion plot on GlowScript. As we can observe, the graph between the two are similar, but they're not the same. The observed motion comes very close to the predicted motion, but is different probably due to friction. The observed motion did not have F net equal to 0, but the computerized version was very close to the observed model. What if my axis were flipped? This would mean that the motion, which was originally in the plus x direction, could go to the negative direction, or even maybe a completely different way. But this does not, and I repeat, does not change the position of the object relative to its axis. This is assuming that we still take the net force as 0, that the change in velocity is still 0. What does it mean? So as we look at the object, we can see the forces acting on the object, on my thread spool holder. And those are the initial force, that is my hand, which is moving towards the right. Then there's the friction by the table, which is opposite to the force by my hand. It is moving towards the left. Then there's the force of table, which is acting going towards the top. And then there's the force of gravity pulling it down. So hypothetically, there could be a specific time where all of the above would cancel each other out to give us the perfect system. Thank you.